Over-tightening circuit breaker lugs can lead to several potential problems. Firstly, stripping of threads. Excessive torque can deform the threads on the breaker lug or bus bar, making it difficult or impossible to remove the breaker in the future. Secondly, damage to the breaker mechanism. Over-tightening can put excessive stress on the breaker's internal mechanism, leading to premature failure or malfunction. Thirdly, heat generation. Over-tightening can cause the breaker lug and bus bar to heat up, especially under load. This heat can damage the insulation or cause a fire. Fourthly, reduced breaker functionality. Excessive torque can hinder the proper operation of the breaker, such as tripping during overload or short-circuit conditions. Fifthly, electrical arc. In severe cases, over-tightening can create an electrical arc between the breaker lug and bus bar, which can be hazardous and cause damage to the breaker or electrical system. There are specific examples from case studies. In 1999, a Navy ship fire aboard the USS Cole was linked to over-tightened circuit breaker lugs. The excessive torque caused the lugs to overheat, leading to a short circuit and fire. In 2013, an explosion in a New Jersey electrical plant was attributed to over-tightened circuit breaker lugs on a transformer. The lugs failed under high current conditions, causing an electrical arc that ignited a transformer fire. The National Electrical Code, also known as NEC, requires that circuit breaker lugs be properly tightened according to manufacturer's instructions. Manufacturer instructions typically specify the required torque values. Using a torque wrench to tighten breaker lugs ensures consistent and accurate tightening. While it may be true that over-tightening circuit breaker lugs has not been widely reported as a major issue, there are potential consequences that can lead to serious safety concerns, electrical malfunctions, and even catastrophic failures. Therefore, it is essential to follow industry recommendations and properly torque circuit breaker lugs according to manufacturer specifications. The correct torque is crucial for proper electrical connections. When connections are not adequately tightened, several problems can arise, impacting the overall safety and efficiency of the electrical system. One of the main issues with loose connections is increased resistance. Even a slightly loose connection can create a significant amount of electrical resistance. This resistance impedes the flow of current, causing the connection point to heat up. Over time, this heat can degrade the conductor and insulation, leading to a higher risk of electrical fires. Another issue is voltage drop. As current flows through a loose connection with higher resistance, a voltage drop occurs. This means that the voltage available at the end of the circuit is lower than the source voltage. Voltage drops can cause equipment to malfunction or operate inefficiently. Motors may run slower, lights may dim, and electronic devices may not function correctly. Another concern is arcing. Loose connections can create small air gaps that allow electricity to arc across the gap. Arcing generates intense heat and can ignite nearby materials, leading to fires. Arcing also erodes the metal surfaces of the conductors, further weakening the connection and increasing resistance. Loose connections can also cause intermittent failures. Vibration, thermal expansion, and contraction can exacerbate the looseness of connections over time. This can lead to intermittent electrical failures, which can be difficult to diagnose and repair. Equipment may work sporadically, causing disruptions in operations and potential damage to sensitive electronics. Another issue is premature equipment failure. The heat, arcing, and voltage drops associated with loose connections can significantly reduce the lifespan of electrical equipment. Motors, transformers, and other devices are designed to operate within specific voltage and current ranges. When these parameters are compromised due to loose connections, the equipment is subjected to undue stress, leading to premature failure and costly replacements. Lastly, there is energy waste. Loose connections increase the overall resistance of the electrical system, leading to wasted energy. This wasted energy manifests as heat, which dissipates into the surroundings. Over time, this energy waste can add up to significant costs in terms of increased electricity bills and reduced energy efficiency. To prevent these problems, it's essential to ensure that all electrical connections are properly tightened and torqued according to manufacturer specifications. Regular inspections and maintenance are also crucial for identifying and addressing any loose connections before they cause significant problems. The purpose of torquing electrical connections is to ensure that the connection is tight enough to provide a secure and reliable electrical pathway without damaging the components involved. Torque, which is a measure of rotational force, is used to tighten nuts, bolts, and screws to a specific tension. This tension creates the necessary contact pressure between the conductors, reducing resistance and preventing loosening due to vibration, thermal expansion, and other factors. Firstly, optimal contact pressure. Applying the correct torque ensures that the conductors are pressed together with the optimal force. This force maximizes the contact area between the conductors, reducing electrical resistance at the connection point. Lower resistance means less heat generation and a more efficient flow of current. Secondly, preventing loosening. Properly torqued connections are less likely to loosen over time. Vibration, thermal expansion and contraction, and other mechanical stresses can cause connections to loosen, leading to increased resistance, arcing, and potential failures. Torquing to the specified value helps maintain the integrity of the connection over its lifespan. Thirdly, avoiding damage. Over-tightening a connection can damage the threads of the screw or bolt, the insulation of the conductors, or the components being connected. This damage can compromise the integrity of the connection and lead to premature failure. Using a torque wrench ensures that the connection is tightened to the correct level without exceeding the safe limits of the materials. Fourthly, compliance with standards. Electrical codes and standards such as the NEC often require that electrical connections be torqued to specific values. These standards are designed to ensure safety and reliability in electrical installations. Following the specified torque values helps ensure compliance with these codes and standards. Fifthly, consistent performance. Using a torque wrench ensures that each connection is tightened to the same level of tension. This consistency helps to ensure that all connections in the electrical system perform optimally and reliably. Inconsistent torque can lead to some connections being too loose and others being too tight, resulting in uneven performance and potential problems. Sixthly, safety. Properly torqued connections are safer because they reduce the risk of electrical fires, equipment damage, and other hazards. Loose connections can cause arcing and overheating, which can ignite nearby materials and lead to fires. Properly torqued connections minimize these risks, creating a safer electrical environment. Using a torque wrench is essential for achieving the correct torque values. A torque wrench is a specialized tool that measures the amount of rotational force being applied to a fastener. It allows the user to tighten a connection to a specific torque value, ensuring that the connection is neither too loose nor too tight. There are several types of torque wrenches available, including click-type, beam-type, and digital torque wrenches. Click-type torque wrenches are the most common type and are easy to use. They have a mechanism that clicks when the desired torque value is reached, indicating that the connection is properly tightened. Beam-type torque wrenches have a pointer that indicates the torque value on a scale. They are less precise than click-type torque wrenches but are also less expensive. Digital torque wrenches provide a digital readout of the torque value, allowing for very precise tightening. They often have additional features such as data logging and preset torque values. When using a torque wrench, it's essential to follow the manufacturer's instructions and the specified torque values for the connection being tightened. Over-torquing or under-torquing can both lead to problems. It's also important to calibrate the torque wrench periodically to ensure that it's providing accurate readings. Calibration should be performed by a qualified technician using specialized equipment. There are several different standards and regulations that address the proper torquing of electrical connections. These standards are designed to ensure safety, reliability, and consistency in electrical installations. Firstly, the National Electrical Code, known as NEC. The NEC provides comprehensive guidelines for electrical installations, including requirements for torquing electrical connections. Section 110.14 D of the NEC requires that all electrical connections be torqued to the manufacturer's specifications. This requirement applies to all types of electrical connections, including those in panel boards, switchboards, and other equipment. Secondly, UL standards. Underwriters Laboratories, also known as UL, develops standards for electrical equipment and components. UL standards often specify the torque values for electrical connections in the equipment they certify. These torque values are based on testing and engineering analysis to ensure that the connections are safe and reliable. Thirdly, manufacturer's instructions. Electrical equipment manufacturers provide instructions for installing and maintaining their products. These instructions typically include the torque values for all electrical connections. Following the manufacturer's instructions is essential for ensuring that the equipment is installed correctly and will perform reliably. Fourthly, industry best practices. In addition to the NEC, UL standards, and manufacturer's instructions, there are also industry best practices for torquing electrical connections. These best practices are based on experience and engineering analysis and are designed to ensure that connections are properly tightened and will perform reliably over time. Industry best practices often include recommendations for using torque wrenches, calibrating torque wrenches, and inspecting connections for proper tightness. Fifthly, ISO standards. The International Organization for Standardization, also known as ISO, develops standards for a wide range of products and services, including electrical equipment. ISO standards often address the proper torquing of electrical connections. These standards are designed to ensure that connections are safe, reliable, and consistent across different manufacturers and products. The consequences of not torquing electrical connections properly can be severe. Loose connections can lead to increased resistance, heat generation, arcing, and ultimately electrical fires. Over-tightened connections can damage the components and lead to premature failure. Both under-tightened and over-tightened connections can compromise the safety and reliability of the electrical system. One common consequence of loose electrical connections is overheating. When a connection is not properly tightened, the contact area between the conductors is reduced, which increases the electrical resistance at the connection point. This increased resistance causes the connection to heat up as current flows through it. Over time, this heat can degrade the insulation on the conductors, leading to a higher risk of electrical fires. Another consequence of loose electrical connections is arcing. Arcing occurs when electricity jumps across the gap between two conductors. This can happen when a connection is loose and there is a small air gap between the conductors. Arcing generates intense heat and can ignite nearby materials, leading to fires. Arcing also erodes the metal surfaces of the conductors, further weakening the connection and increasing resistance. Loose electrical connections can also cause voltage drops. As current flows through a loose connection with higher resistance, a voltage drop occurs. This means that the voltage available at the end of the circuit is lower than the source voltage. Voltage drops can cause equipment to malfunction or operate inefficiently. Motors may run slower, lights may dim, and electronic devices may not function correctly. Intermittent failures are another common consequence of loose electrical connections. Vibration, thermal expansion, and contraction can exacerbate the looseness of connections over time. This can lead to intermittent electrical failures, which can be difficult to diagnose and repair. Equipment may work sporadically, causing disruptions in operations and potential damage to sensitive electronics. Loose electrical connections can also lead to premature equipment failure. The heat, arcing, and voltage drops associated with loose connections can significantly reduce the lifespan of electrical equipment. Motors, transformers, and other devices are designed to operate within specific voltage and current ranges. When these parameters are compromised due to loose connections, the equipment is subjected to undue stress, leading to premature failure and costly replacements. In addition to these consequences, loose electrical connections can also increase the risk of electrical shock. If a connection is loose and a person comes into contact with the exposed conductor, they may receive an electrical shock. This is especially dangerous in wet or damp environments, where the risk of electrical shock is higher. To prevent these consequences, it's essential to ensure that all electrical connections are properly tightened and torqued according to manufacturer's specifications. Regular inspections and maintenance are also crucial for identifying and addressing any loose connections before they cause significant problems. A qualified electrician should perform all electrical work and use calibrated torque wrenches to ensure that connections are properly tightened. Regularly inspecting and maintaining electrical connections is essential for ensuring the safety and reliability of electrical systems. Over time, connections can loosen due to vibration, thermal expansion and contraction, corrosion, and other factors. Regular inspections can identify these problems before they lead to more serious consequences such as overheating, arcing, and electrical fires. Firstly, visual inspections. Visual inspections should be performed regularly to check for signs of loose connections, such as discoloration, corrosion, or physical damage. Look for any evidence of overheating, such as melted insulation or charred components. Also, check for any loose wires or connectors. Secondly, thermal scanning. Thermal scanning, also known as infrared thermography, is a non-destructive testing method that can be used to identify hotspots in electrical connections. A thermal imaging camera is used to scan the electrical system, and any areas of abnormally high temperature are identified. These hotspots may indicate loose connections or other problems that need to be addressed. Thirdly, torque tester. Torque testing involves using a calibrated torque wrench to check the tightness of electrical connections. The torque wrench is set to the specified torque value for the connection, and the connection is checked to see if it meets this value. If the connection is loose, it should be tightened to the specified torque value. Fourthly, ultrasonic testing. Ultrasonic testing is a non-destructive testing method that can be used to detect loose connections by measuring the sound waves that pass through the connection. Loose connections will typically have a different sound signature than tight connections. Fifthly, vibration analysis. Vibration analysis can be used to detect loose connections by measuring the vibration levels of the electrical equipment. Loose connections will typically cause higher vibration levels than tight connections. The frequency of inspections and maintenance will depend on the specific application and the environment in which the electrical system is operating. In general, electrical systems in harsh environments or those that are subject to heavy use should be inspected and maintained more frequently than those in milder environments or those that are used less often. The NEC provides guidelines for the frequency of inspections and maintenance in different types of electrical systems. Additionally, it's essential to keep records of all inspections and maintenance activities. These records should include the date of the inspection, the findings of the inspection, and any corrective actions that were taken. Keeping accurate records can help to identify trends and prevent future problems. When performing inspections and maintenance, it's essential to follow all safety precautions. Electrical work can be dangerous, and it's important to take steps to protect yourself from electrical shock and other hazards. Always de-energize the electrical system before performing any work, and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. It's also important to be aware of the potential for arc flash, which can occur when working on energized electrical equipment. Arc flash is a sudden release of electrical energy that can cause serious burns and other injuries. To protect yourself from arc flash, wear appropriate arc-rated clothing and use arc flash protection equipment such as face shields and gloves. In addition to these general safety precautions, there are also specific safety precautions that should be followed when working on different types of electrical equipment. For example, when working on transformers, it's important to be aware of the potential for high voltage and to take steps to prevent electrical shock. When working on circuit breakers, it's important to be aware of the potential for arc flash and to use appropriate arc flash protection equipment. By following these safety precautions and performing regular inspections and maintenance, it's possible to ensure the safety and reliability of electrical systems and prevent costly and dangerous problems. The key to properly torquing electrical connections is following these steps. Firstly, consult manufacturer's specifications. Always refer to the equipment manufacturer's specifications for the correct torque value. These specifications are usually found in the equipment's installation manual or on a label attached to the equipment. Secondly, use a calibrated torque wrench. Use a calibrated torque wrench to ensure that the correct torque is applied. Calibrate the torque wrench regularly to ensure accuracy. Thirdly, clean the connections. Clean the electrical connections before torquing to remove any dirt, debris, or corrosion. Use a wire brush or a specialized electrical contact cleaner. Fourthly, apply the correct torque. Apply the torque slowly and evenly using a smooth, steady motion. Avoid jerking or over-tightening the connection. Fifthly, verify the torque. After torquing the connection, verify the torque value using the torque wrench. This will ensure that the connection is properly tightened. Sixthly, inspect the connection. Inspect the connection for any signs of damage or distortion. If the connection is damaged, replace it before energizing the circuit. Seventhly, re-torque after installation. After the equipment has been installed and energized, re-torque the connections after a period of time, such as 24 hours. This will allow the connections to settle and ensure that they remain properly tightened. Eighthly, document the torque. Document the torque values and the date of torquing for each connection. This will provide a record of the work that was done and will help to ensure that the connections are properly maintained in the future. Ninthly, train personnel. Train personnel on the proper procedures for torquing electrical connections. This will ensure that all connections are properly tightened and that the equipment is safe and reliable. Tenthly, follow safety precautions. Follow all safety precautions when working on electrical equipment. This will protect yourself from electrical shock and other hazards. By following these steps, it's possible to properly torque electrical connections and ensure the safety and reliability of electrical systems.